So as I promised that after the introduction to inequalities, we're going to do the actual problem solving. Now we're going to solve problems that we encounter in an exam or an assignment format type of a thing. But before we cross that bridge, here's some things I need to pass through first. We need to remember that for cases, previously I did mention that when you have cases where you have x is greater than 3, for instance, to represent this on a number line, you're just going to show your number line like that, and then the value 3, because x is greater than 3, greater and equals to, it means we're going to show our circle, because it has an equal sign underneath, and then we shade our circle, meaning 3 is included. Therefore, this is how we're going to represent this in a number line. Again, for cases where it's just x greater than 3, without an equal sign. So we don't include the 3, it's just anything more than 3, but 3, because there's no equal sign underneath. And then we said we show in the form of a circle, and then it shows like that. We have cases where x is between two values. For cases where x is between two values, we're going to have something of this form. X could be between, say, a random value. I can choose 7 and 2. So meaning x is greater than 2, but x is less than 7. So x is between 7 and 2. In a number line, we would represent this like something of this form. It would be 2 here, it would be 7 here, because 2, 3, 4, 5, 6, 7. And then we're going to shade this part here. We're going to shade this part here. We know that this one goes that way. And then we know that this one goes that way, because x is greater than 2. X is greater than 2, but x is less than 7, but x is less than 7. And then where the arrows meet, that's where we get our solutions. Hence we say x is between 7 and 2. So this is where the solution is, right here in between. So now you will get awesome students showing you something like this. You will get awesome students trying to relate to in between by showing you something like this. Guys, you will never, ever get anything like this. This does not exist. You only have one case for in between, which is this. Both the arrows are facing that direction when the value of x is in between. Both the arrows are facing that direction. And this side you have a bigger value, this side you have a smaller value. You must always look at it like that. So this is like what I'm saying. In between, I don't care if you think of this as framework or not, but then if x is in between, we have these cases, bigger value this side, smaller value this side. Smaller value this side, and the signs are facing this direction all the time. You won't have this, you won't have this. This doesn't exist, not in the mathematics of our curriculum. This here, actually forget about this. You either have x to be between two values, which is the bigger value this side, the smaller value this side. Otherwise, you may get a case where x is greater or equals to 7, or x is less than or equals to 2 if they are not in between. And on a number line, this may look something like this, 7, 2. So it's either x is greater or equals to 7, going that way, or x is less than or equals to 2. So these are the two cases you may have. Either you have in between, So these are the two cases you have. You either have in between, where x is in between 7 and 2. That's where the solution is. Or you either have where x is greater than 7 or x is less than 2. This is the case with the number line. This information I just shared right now is very much important if you find these things complicated. Like, just pause, go back, listen again, just to make sure you understand what do I mean. But then, because I'm a good person, I'll go furthermore to give more examples before we actually solve our questions. So now, picture something like this also. Now, this is how we get our solutions based on a number line. Suppose you have simplified your quadratic function, and then you get something like this. They say this is greater or equals to 0, right? To get the solution for this, you have to plot the number line first, and then the solution will automatically come out from the number line itself. So this is the rule. You're going to show your number line. You know that if this was an equal sign, x would have been positive 2. Also, x could have been negative 4. So this is how the number line shows. So to get our solution, we say the original sign, the sign that you get on the equation after you simplified it to that form, this sign will give it to the bigger number, and then the smaller number opposes this sign. So 2 is greater or equals to 0. It's going to go that side. I'm going to shade it, and then I'm going to show it goes that side. And then 4, which is lesser than 2, is the smaller number. It opposes the direction. So we're going to shade it like that, and then it opposes the direction and go that way. Meaning our solution for this one, it will be x is greater or equals to 2, or x is less or equals to minus 4. This is our solution for this. Now, things change now. Instead of greater now, after simplifying, we find that our equation ends up being this less than 0. Again, to get the solution of this, I put everything on a number line. I know that if this was an equal sign, x would have been positive 2, and also x would have been minus 4. 2 is the bigger number, minus 4 is the smaller number. And I say the rule states that the bigger number takes the sign as it is. So 2 is going that way. And then the smaller number opposes. So if 2 goes that way, the smaller number also will shade. It goes to the opposite direction. So the original one goes to the direction of the sign, and then the smaller number opposes the direction. That's just the rule you use to get the solution. So we see that both the arrows, they interact here and here, which means that our value of x is between 2 and minus 4. And as you can see, between only has 2 arrows that are facing that direction, and a bigger number this side and a smaller number this side. That's how we get this. Furthermore, sometimes we may get a situation like this. To solve here, again, we represent it on a number line. We know that x is minus 3 or minus 7. Mind you, minus 3 is bigger than minus 7. So the bigger one takes the original sign as it is. So minus 3, since it's a bigger one, but we don't shade it this time around because there's no equal sign underneath the greater than. So it's going to be like that. And then also for this one, meaning 3 is not included, it just go that way because there's no equal sign underneath. So for this one, it's going to be minus 7. Since the bigger one went the original direction of the sign, the smaller one will oppose the bigger one. Therefore, our solution here, we say x is greater than minus 3, or x is less than minus 7. That's the solution for this. This is how we get the solution. As you can see, now it's a different story. We have less than sign now. Same values, but the sign now is going that direction. So again, to get our solution, we show the number line first. And then we know that if x was, if there was an equal sign here, x would have been minus 3 and minus 7. And I arranged this in a number line like this because according to a number line, minus 3 is bigger than minus 7 because it's 0, minus 1, minus 2, minus 3, minus 4, minus 5, up until minus 7. So we say the bigger one takes the sign as it is, but I don't shade it because there's no equal sign underneath. This will go to that direction. And then the smaller one opposes the original sign. This will go to that direction. And then we can see that both the arrows, they interact here. This is where they interact, and then that one goes like that, singular, that one goes like that, singular. And then we say our solution for this one, x is between minus 3, minus 7. But then we don't put the equal sign anymore because it's not included there. We take it as it is, but then the bigger one this side, the smaller one this side. Still, again, the arrows are facing that direction. So I do mean it that you will never, ever, ever, ever in your life get something like this to this direction. Never. No, don't even think about it like that. So now I think that at this point we have gathered enough information to can attempt our questions, and these are the questions we're gonna answer. We'll do them one like that. Let's start with the first question without wasting time. So our first question, we have x squared is greater than 3, x plus 6, just like that. It's given like that. And then to solve this, we'll have x squared is greater than, if I multiply the 3 with what is inside, I'll have 3x plus 18. Therefore, now I just want to bring this to the other side so it can be a quadratic equation like that. So I have, it's going to change signs and becomes that. It's greater than 0. So if I take minus 3 to the other side, it becomes minus 3x. If I take plus 18 to the other side, it becomes minus 18. So now I can factorize this. To get the factors of this will be, for x, I know I'm going to multiply x and x. Now, in order to get minus 18, while I maintain minus 3x, I know that my factors will have to be 6 and 3, because 6 times 3 does give me 18, and also 6 minus 3 does give me 3, like that. But then because this is a negative, it means the bigger one will be a negative and the smaller one will be a positive. So this is how I factorize this to that. If you can't factorize this and you are in an exam, don't waste your time too much. Let's go straight and use the quadratic formula. It will give you the very same factors as this. Otherwise, you can watch other videos where we're teaching how to factorize. Therefore, from here, I know that if this was an equal sign, x would have been positive 6 or minus 3. So applying the rules to get the solutions, we know that 6 is the bigger value, minus 3 is the smaller value. The bigger value takes the original sign of the inequality. So I'm not going to shade it because there's no equal sign underneath. It will go that way. And then minus 3, it will oppose the original sign after, because it's the smaller one. Therefore, our solution here will say x is greater than 6 or x is less than minus 3. This is our solution for this one. Great. For the second one, we have x squared minus 2x minus 8 is less than 0. X squared minus 2x minus 8 is less than 0. Factorizing that, we will have, to get x squared, I know I'll multiply x and x. To get 8, while I maintain the 4, I know 4 times 2 gives me 8, and also 4 minus 2 can give me minus 2. Since it's a negative here, the bigger one will have a negative number, the smaller one a positive number. And then now to get the solution again, I show my number line. I know that 4, it's positive if this was an equal sign, and minus 2 there. Now, the original one, the bigger value takes the original sign, the smaller value opposes the bigger value sign. So the original sign is less, so this one is going to be like that. I'm not going to shade it because there's no equal sign underneath. This is going to go to that direction, and then this one will oppose that and go to that direction. Somehow we can see that the arrows interact between here and here. That's how we can say our solution is x is less than 4, but x is greater than minus 2. So we say x is between 4 and minus 2. Again, the arrows are facing that direction. Bigger number this side, smaller number this side. So the next one is this one. Again, if you find it challenging to factorize this one, you can just go straight and use the quadratic formula to factorize this. Otherwise, to get the factors of this, now, to get 2x squared, I must just multiply 2x and x. And to get 6, it could be 6 and a 1 or 3 and a 2. But then I must consider x as a middle term. Somehow, if I use 3 and 2, while considering that 2 times 2 will give me 4x and the 3 can subtract to give me 1, and then I choose my factors to be 3 and a 2. And then because it's a positive here, the bigger number is not going to be 3 in this case, it's going to be 4, because 2x multiplied by 2 is going to give me 4x, and then I'm going to put a positive here and a negative there. Like I say, you need more practice to master your factorization. If not, and you know you are not that good in factorization, you can just go straight from here and use the quadratic function to get the factors of this. Therefore, now I'm going to show this on a number line again. I know that if this was an equal sign, I know that somehow the bigger number here could have been 3 over 2. This is going to give me 3 over 2 because it was going to be like 2x minus 3 is equals to 0. Therefore, 2x is equals to 3. Therefore, I divide by 2 there, divide by 2. This will cancel that. That's when I would get 3 over 2. So I know that this would give me 3 over 2. So I'm going to put the positive 3 over 2 here. It's actually 1.5, but let me just put it as 3.2, 3 over 2. And I would get minus 2 as well for this side. Now, the bigger value takes the original sign as it is. This is my bigger value. But then since there's an equal sign underneath, so it's less or equals to, I'm going to shade it. Then it's going to go to that direction. And then minus 2 is like that. It has to oppose the bigger sign as it was given. And then I'm going to shade it as well. And then it goes to that direction. So we can see that they interact here and there. Therefore, that's when I say the solution for this is x is less or equals to 3 over 2, greater or equals to minus 2. So this is the solution for this. Then we move to our last one. Again, if you can't factorize this directly, you can just go ahead and use the quadratic formula to factorize it. But otherwise, if we get our factors here, our factors will be, to get 2x squared is going to be 2x and x, obviously. And then to get 1, it's just 1 and 1. But then to work around our signs here, we know that if I multiply this by 2, it's going to be 2x, and then this one is going to be x. But then since we have a negative here, I'll give a bigger one negative. And I'm looking at this as a bigger one because by the time I multiply it by 2, it's going to be bigger than 1. So this one will be positive then. That's how I get my factors. And then to get the solution again, I show my number line there. And then from my number line, I know that this would have been minus half, minus 1 over 2, if this was an equal sign, and this would have been positive 1. Again, the bigger number is 1, the smaller number is minus half. Therefore, the bigger number takes the original sign as it is, and then I shade it because there's an equal sign underneath. It's going to go that direction. And then the smaller one, it opposes it like that. It goes to that direction. Therefore, this is how it goes. And then our solution would then be x is greater or equals to 1, or x is less than or equals to minus 1 over 2. So basically, this is how it's done. This is how you solve your inequalities. For today, I think we're going to stop here. Join me on the next video as we explore more knowledge. I'm Mr. My Money. This is Simplified RSA, the guys who makes it look easy. Please make sure you subscribe on our YouTube channel. Follow us on Facebook, follow us on X, follow us on Instagram, as well as TikTok. And also, you can access our learning channel through Spotify. All you need to do is just to go to your Spotify app and type in learning channel, or alternatively just simplified_RSA, and then you can access our learning channel as well. I'm out.